Welcome to Examrace. This is the classical mechanics, and we are here to learn about the rigid body and its moment of inertia. We cover the almost every part of the rigid body, but we remain with a certain important part, that is what the moment of inertia and basically the moment of inertia of a tensor. So here first we learn about the rotation about fixed point. As we know what is the rotation and all other things. Rotation, angular momentum, and torque, all we have already learned. But what we are here for the system of particles or a rigid particle when it is rotating about any certain axis, and that axis is this one. Okay, this is what axis. About this axis, a 3D object is rotating, and the 3D rigid object has n number of particles. Suppose this is the ith particle that I have taken in an example. This is the ith particle and that is rotating about this axis. Now this particle is making a circular path like this. This is what a circular path we have. Okay, so this circular path has certain radius. Now we have defined certain axis, x-axis, y-axis and z-axis. Z-axis it is outside the screen, and x and y axis are shown as in the figure. Now this particle is at distance ri. Ri is what the distance of ith particle. This is n number of particle or I number of particles. I picked the one particle, and that particle named as ith particle. This particle makes an angle with the axis. Also, axis means rotating, the axis about which the particle is about which the body is rotating, or system of particles is rotating. So this particle is making angle. That angle is alpha I, and the distance of this particle from the origin of the coordinate system is ri. Now we have to find the distance, or if I say the radius of this circular path. So radius of circle of ith particle, radius of circle for ith particle is it's ri sine alpha I. Fine. Since the particle is rotating in a circular path, so it has certain velocity, and that velocity is that we have taking the velocity is the tangential velocity. For example, the circular path is like this, and this is the radius of that circular path, and the particle is moving with the velocity. That velocity is what we call tangential velocity. Fine. So tangential velocity of ith particle. What is this tangential velocity of ith particle? See, this is the circle of radius r, and it has certain velocity. Now the circle is having the angular velocity omega, and the tangential velocity is this. So can I say the relation between omega and r is v is equals to omega r? Is it? So tangential velocity is v equals to omega r. Omega r I. Fine. This is what omega r I, and this velocity I denoted as vi. Vi is the velocity of ith particle, which is omega r I. Okay. Just put the value of ri. So vi is equals to omega, or it's better to see it as r. V is equals to omega r. R is the radius, and radius is defined as this. Clear? Radius is ri sine alpha I. So let's put the value of r. This is ri sine alpha I. So this is what is speed, because it has magnitude. But if we talk about the vector quantity, then it's going to be omega cross ri. and this is what I got, velocity of the ith particle. Clear? Always remember, just write this as omega cross r, not r cross omega, because it is an incorrect form of writing the velocity. So the correct form is v is equals to omega cross r. Clear? Now